Come to the question number 3. Prove that the following are irrational. Third of first 1 upon root 2. I have to prove this as irrational. Okay. First of all, I assume this number as rational. First of all, I assume this as rational. If this is rational, I again write in the form of a upon b, where b is not equal to 0. Then 1 upon root 2 is equal to a upon b, where b not equal to 0 and a and b are co-prime numbers. Co-prime numbers. Now you are very much familiar with this name, co-prime numbers. Means SCF is equal to 1. Now squaring on both sides. Squaring on both sides. On squaring on both sides, this become like this, and this become like this. Means 1 upon 2 is equal to a square upon b square. Then you do cross multiplication. 2a square is equal to b square. Means b square is the multiple of 2. Means 2 can divide b square. 2 divide b square. Then from the theorem of arithmetic theorem of fundament, if 2 divide b square, then 2 divide b. From the theorem of arithmetic, fundamental theorem of arithmetic. Now I can write b is equal to 2c, where c is any positive integer. C is any positive integer. I put this value in the equation number this. Okay. 2a square is equal to 2c square. Means 2a square is equal to 4c square. To divide this, you get this. Implies that a square is equal to 2c square. Again, same theorem. I can say that if 2 divide a square, then it divide a also. The same theorem, fundamental theorem of arithmetic. From this and this, I can say that 2 is a common number between a and b. Here I suppose a and b are co-prime number. Again contradiction arises. From 2 and 3. From 2 and 3, 2 is the common number. Common number between a and b. But, and this contradicts our assumption. this contra this contradict our assumption. Okay, and because of that, whatever we assume above become wrong. So under root 2 which we assume under root 2 which we assume as rational was wrong, hence it is irrational, hence it is irrational. Okay, I hope you understand. Come to the second part of this question, that is 7 under root 5 as irrational. I have to prove. Again, same thing. I let this is rational. Let us assume that 7 under root 5 is irrational. Okay. If this is rational, then I can write in the form of A upon B. Where B not equal to 0 and A and B are co-prime numbers. I feel you don't require to explain this term. Okay, here I can write like this also. A upon 7B. From this is a rational and this is a rational and rational. A, B and 7 are rational. When we divide a rational by rational, we get a rational. Means A upon 7B is equal to rational. It means 105 rational? No, it can't be possible that this is rational, because we know the fact that 105 is irrational, and this thing arises because of our assumption which we made above. As this rational, so under root 5 is an irrational. Okay. I hope you understand this also.
1.
Come to the third part. I have to prove this also as irrational. Again, we have to follow the same method which we followed earlier. In this also we assume 6 plus under root 2 as rational. If this is rational, we can define in the form of a upon b, where b is not equal to 0. Okay, start. Let us assume that 6 plus under root 2 is a rational. If it is a rational, then we can express in the form of a upon b, where b not equal to 0. b 0 के इक्वल नहीं होगा. Means I can write like this: a upon b minus 6. This is rational and this is rational. When we subtract irrational from rational, we get rational. If this is rational and this is equal to this, it means under root 2 is also rational. And we know the fact that under root 2 is irrational. The fact is that under root 2 is an irrational. And this contradiction arises, and this contradiction fact is irrational, and from my solving this is rational. This thing arises because of our assumption. This contradiction arises because of our wrong assumption. Okay, because of our wrong assumption. So 6 plus under root 2 is an irrational. Hence proved. I hope you understand the exercise 1.3 completely. If you have any doubt, then you can ask me anytime through either your comment box also. Okay, bye.